Hello everyone. Today I'm going to present my final project and just bear with me a moment. I'll share my screen. So my final project is AI based threat monitoring and risk assessment system. So this is my first chapter. Let me give the introduction of this. So as you guys know that this has been lot of AI models, AI training models out there in the market. But in order to build an AI system, as you guys know, data set is compulsory. Training the data is compulsion to build a reliable AI system because the AI learns through the data. So when you depend a lot on data, it is also a problem because when the data is not the right data, or if the data gets poisoned accidentally or intentionally, then it's going to cause a lot of problems. So my project revolves around this idea to prevent the data poisoning or the data intentionally or not intentionally. If the data is out of boundary or data is poison, my system detects such kind of data and it monitors those data, and it provides a interactive web-based solution wherein you can see that if the data is poisoned, or it is most likely data which is not fits well with the system. It immediately identifies those datas, and it gives it a score, and lets the user know if he has to pass that data or that information. So my project revolves around that. So it's the hybrid AI threat monitoring system. So basic concepts which I used in this is that it used the drift data drift and the gradient statistics, and it applies algorithms like Bayesian inference method. And it like I already explained, it has an interactive dashboard as well. And yeah, this is my introduction. So the agenda for today is that I've already explained the introduction, which I've shown you. So I'll explain about the introduction, then I'll go to the literature review, which I've carefully read through a lot of papers, and then I'll go into the methodology, how I implemented all of this, and then after methodology, I'll review about the results, what are the outputs I've got, and in fifth one, I'll do a discussion about the results, and then in sixth, it's the conclusion. So let me go over each topic very carefully. So, so this is my literature review. So I've read through various articles, but I've compressed and I've picked top four articles of my literature review, and I'll try to explain about these literature reviews. So the first one is the hybrid AI framework for real-time fraud detection in cross-border and digital payment ecosystem. So this is a system wherein it identifies, it's an AI system which identifies if the fraud is taking place, or it identifies the emerging fraud patterns. But the only weakness with this system is that it doesn't go deep into the historical data, so the responsiveness may decrease, and for the international payment environment, it is not reliable. So this is about the first article I've read through, and then I've read through this the other article, that is real-time AI monitoring for a distributed and hybrid cloud environment. So this is for the cloud environment. Uh, it for So this paper focuses on the complexity of the AI monitoring in distributed and cloud infrastructure. Uh, so a significant strength is that it is very scalable and latency aware design, so it doesn't have any latency, as well as it is essential. So this design is essential in multi-node environment. However, there is a limitation also for this one, unfortunately, that is it there is a uh, there is not a good strategy for anomaly detection, which is a problem in a long run. And next is the advanced decision making in AI through Bayesian inference and probabilistic graphical method. So this can be used in my algorithms as well, because I was thinking of using the Bayesian inference method in my particular project. So this is uh, correlated, and it is helpful for me to use the concepts of this research paper. So this is a study in which they utilize Bayesian inference and probabilistic graphical methods, so that the AI does the decision making in certain situation. So there are which has a lot of strengths. That is, it has a interpretability and ability to update the beliefs dynamically with new data. So those are, advantages of using this method. But there is also one limitation, that the computational complexity is very high, so it takes a lot of time to uh, to process the information, which is a kind of a drawback for this situation. So that's about that. And then lastly, AI enabled data quality monitoring use with Hydra. So when monitoring data, human-centric data, which was automized by introducing this Hydra. So they use the Hydra concepts, and they automated this by using the Hydra concept. So what they did is they used the AI powered system and used the concepts of TensorFlow and Inception V3 for image based anomaly detection. So instead of a person reviewing all of the data, physics, high energy physics data, which was produced, which is image based data, instead of a person doing it, they have introduced the Hydra concept, which is a AI concept which is powered using these TensorFlow and Inception V3, which does the anomaly detection. This can be used in the concept that the uh, even we use anomaly detection, but we don't use image-based anomaly detection. But it can be used. The anomaly detection concepts can be implemented in my paper. So I went through this research article as well. So this is about my research in literature review. And the next slide is this is my methodology. So I've used the approach I used is modular, agile, and uh, GIT development. GIT stands for just-in-time development method. So it integrates two concepts, that is agile and as well as JIT, just in time. So there we don't have time to implement all of the data. We don't have a lot of time to develop the app, so we just implement the concepts which are required for the app, because time frame is also important while developing an web-based solution, not web-based app. So I'm using JIT as well as agile, because uh, it the app has to be always improved and updated. Since my app is also AI based system, it needs new data and it needs new information, so it needs to be updated from day to day. So I use agile with uh, JIT development. And for the framework, the front end, I use React JS, as well as combination of React plus Chat JS. And for the backend, I use Fast API. And for the machine learning, I use PyTorch for the wrapper methods. And for threat scoring, I used the Bayesian inference method. So, and for the ethics, I use the privacy, fairness, and GDPR compliance. So, I've kept all of these in mind for privacy, and it is GDPR compliance data, which is based on it. So, about my chapter 4 is it's about how the data is. So this is the live web based app. So over here you can upload your data set. You can choose a file, you can upload the data set, and it gives you preview of all the everything which is present in your data set. And it also gives you which of the columns are numerical columns. As you can see here, I've taken an example of a BMW sales data set. So as you can see, these are all numerical data sets, and then you can train this model on you can train this model. And this the only constraint with this model is it uses logistic regression method. So it it doesn't predict numerical data. So in this case, I'm not predicting the numerical data. It's the sales classification, which is basically a yes or no, if the sales classification is high or low. So I'm training the data according to the sales classification to predict the sales classification column. And when you hit train, then the data set, it goes through the data set and it trains, and it gives you the metrics of all of the data which was trained. As you can see, the accuracy and everything. And then the third step is the most important step, wherein you given your after the after the model is trained, you pretty much have the model in hand, which has 99% accuracy, which is pretty good. So when you input the data into the trained model, you can see that y hat is the predicted outcome. So in this particular case, it says 1, which is yes. So that is it. And the anomaly score says that the amount of if the score is high, it means that the data inputted is not good data, which is most likely poison data. So drift alert is, if the anomaly score is high, it says that the take in consideration drift alert as true. It needs to be calibrated, so it's still saying it's false, but it has to be true because it's 0.6659, so which is a high number. And if it is below zero point 0.2, then it has to say that drift alert is false. And the threat score concept is also pretty much the same thing as the anomaly score. And then the sample data says that since I've inputted only few values, it says that it's undefined. But if there's a lot of more samples, it would say that the data is sample. And that's about the overview. And then let me come to the chapter 5, which shows how uh, which tells us about the discussion of the output results. So uh, from the output results, we can say that the output results is they are very reliable. uh, uh, the data is very reliable and it works pretty good with the logistic regression models, and it is scalable because it's a web-based application, and it is scalable through all pretty much any smart device with web browser like Google Chrome or any other browser. It is scalable, so it's very scalable. And as you can also see that the accuracy is also pretty good, and it can even detect the anomaly score. So I can say that it is reliable also. So it is the practical, let me go through the implications. Practically speaking, it identifies the threat pretty fast, so that is a good sign. And then the academics, if we see about academics, this can contribute to also the AI framework. Our model can contribute to the AI framework. And limitations is that as we are using logistic regression model with combination with isolated forest, the problem is that it doesn't doesn't predict or doesn't give prediction on numerical data. It only gives prediction on yes or no data, or uh, yeah, yes or Boolean type data. So this is one of the limitations, and the also the data set needs to be pre-cleaned. So that is also one of the limitations. And for the future work, it can be integrated with the federated learning and deeper models for the future. Yep. And to summarize what I've said, this is the chapter 6, which is a conclusion. So contribute is this is a end-to-end web-based monitoring system, which is user friendly, which has a user friendly interface where we can upload the data set, train the data set, and then look at the results if the data inputted is poison or not. It as you have told it, it uses the Bayesian modeling and telemetric analysis, uh, and then the impact, it helps secure machine learning pipelines in finance, healthcare, etc. And closing reflection is that AI security is optional and not foundational. And also to add, the whole conclusion is that I started off this project by thinking that I would also create a wrapper class wherein it actively ingests the model. When the model is running, it takes in the values. Through the values, it gets trained automatically, and it creates the model by itself on the live data. And then it does the threat monitoring system, and it gives the user if the data is most likely poisoned, and it goes through all the data. This is how I started, but due to the time constraint, and due to few of the limitations, I couldn't totally finish the app, which I want to continue in future models also. So in future, I would like to expand my model, making it compatible with all type of prediction models, like numerical model as well as logical regression models. It automatically analyzes the type of model which has to be used, and it goes through a couple of models and picks the model which is most likely closest to the closest which closely fits the model. Example, let's say that if there is a data set which does well with the logistic regression model, then I would choose logistic regression model. But if there is another data set which fits well with the uh, with other models like uh, basic other model, then I would go with the other model, numerical model. So that would be for future, as well as the data. Even if the data is not cleaned, the model automatically cleans the data by eliminating those data. And also it uses concepts like uh, one hot shot encoding for future model, and also uh, use some concepts like fine tuning the model and applying weights and biases to the model to make it more accurate and more focused in one particular application, like we have mentioned, finance or healthcare. Yep. So this is about my project. Yep. Thank you, guys.